Hi everyone, this is Bob the Science Guy. Before we start our discussion of Newton's second law, let's just go ahead and follow through a little bit on our last discussion. So once again, I've got my multimeter on my notepad. We talked about the idea of static versus kinetic friction. Now when the mass of the multimeter is sitting flat on the table, the normal force equals the force of gravity. As we start to raise the incline, there comes a point where we overcome the static friction and the multimeter begins to move. Now once again, if we look at our flat surface and we have a 1 kilogram mass, the force of gravity pulling down on that object is the weight, and that is 9.8 times 1 kilogram, or 9.8 newtons. And this is also going to be 9.8 newtons, but in the opposite direction. So if that's a negative direction and that's a positive direction, the net force on the object is 0. But again, what happens if we pull it with a force in that direction? Well, the force that opposes that is the force of friction, and there are two different types of friction. When the block is sitting on the table, we have something called static friction. And that is the friction that opposes the block moving. So in other words, that's what's holding this multimeter on the table. And until I pull strongly enough to overcome it, that multimeter will not move. But once it does start moving, the resistance to that movement is less. Now, static friction is a little more complex than kinetic friction, because when we talk about static friction, we say that the block has enough friction to overcome up to 10 newtons of force. So if we apply, say, 5 to 10 newtons of force in the opposite direction, we will not be able to get this block to start moving. It's not until we exceed 10 newtons that the block will start to move. So if we have a free body diagram of our block here, the normal force and the force of gravity are equaling each other, so there's no net movement up and down. If I apply 5 newtons of force in this direction, and static friction is up to 10 newtons, that means that my frictional force in that way will still only be 5 newtons. Whatever is needed to make this a net zero force. So if we increase it up to 8 newtons, well, that will increase to 8 newtons as well. So while it may be difficult to start the object moving, once it starts moving, it slides a little bit easier. We've seen this all in life. Imagine moving a refrigerator. When you first start pushing on the refrigerator, it's very difficult to get it moving. But once you get it moving, it's easier to push and it continues to go. That's the difference between kinetic friction, which is the friction as it's moving, versus static friction, which is what we have to overcome to get it moving in the first place. Now let's finish up this video with a situation where we have applied enough force to overcome the static friction. So static friction maxed out at 5 newtons, and we applied 6 newtons. So we've gotten the object moving. Well, now the kinetic friction kicks in, and kinetic friction may only be 3 newtons. So what's the net force on our block? Let's do another diagram real quick. So we've got the block in motion now, and we're applying 6 newtons in that direction. The kinetic friction is applying 3 newtons in the opposite direction, so our net movement equals 3 newtons. That's the basic difference between static friction and kinetic friction. So in this episode, we went over Newton's first law of motion. An object at rest remains at rest or in uniform motion unless acted upon by an unbalanced force. We learned how to do free body diagrams to understand the forces acting on an object. And then we briefly discussed the concept of static and kinetic friction. In our next episode, we're going to talk about Newton's second law, which is force equals mass times acceleration, and see the implications of that. So until then, this is Bob the Science Guy. Thanks for stopping by. More to come.